Benvenuti a tutti a questo nuovo seminario sui materiali compositi che abbiamo organizzato in collaborazione tra SmartCAE, Tech Value e Siemens Digital Industry Software. Io sono Francesco Palloni, fondatore di SmartCAE, esperto di simulazione al calcolatore. Oggi non sarò il solo relatore, ma saremo tutti quanti in ottima compagnia. Insieme a me abbiamo in collegamento Abedin Gagani di Siemens, responsabile dello sviluppo del portafoglio delle soluzioni dedicate all'industria dei materiali compositi, e Jan Goddard, responsabile delle partnership dell'area tecnica e innovazione del team di Formula 1 Alpine. Per chiarezza vi anticipo che gli interventi miei e di Abedin saranno in lingua italiana, mentre la presentazione di Anna sarà in lingua inglese. Questo evento si colloca nella nostra serie Progettare e costruire in compositi, una serie che abbiamo inaugurato lo scorso anno e della quale potete vedere la registrazione degli interventi sul nostro portale dei webinar oppure nel nostro canale YouTube. Oggi parleremo degli strumenti e delle tecnologie di Siemens per semplificare e rendere più efficiente la gestione dei manufatti in materiali compositi, partendo dalla fase di progettazione fino alla gestione dei dati di produzione. Godremo di un punto di vista privilegiato, quello di un team di Formula 1, utilizzatore storico di Fibersim. Nel prossimo episodio, che terremo il 22 ottobre, parleremo con maggiore dettaglio della piattaforma Fibersim, concentrandoci sui benefici di questa soluzione per le aziende di trasformazione dei materiali compositi. L'ospite del prossimo episodio sarà Sparco, un marchio molto noto per gli accessori e l'abbigliamento del settore racing. Quello che forse non sapete è che Sparco possiede anche una business unit che si occupa di produrre componenti in composito per gli OEM automobilistici. Sparco ci parlerà delle loro sfide e di come Fibersim stia dimostrando un valido supporto al loro business. Ecco l'agenda dell'incontro. Una brevissima introduzione per presentarvi le nostre aziende e introdurre il tema di oggi. Dopodiché lasceremo la parola a Jan Goddard che ci spiegherà come vengono progettate, studiate e realizzate le parti in composito all'interno di Alpine Formula 1. Una breve conclusione per riassumere i punti principali di quanto abbiamo visto e la sessione di domande e risposte nella quale potete sottoporre a me e a Abedin e Jan i vostri quesiti. Per le domande dovete utilizzare il pannello che qualcuno ha già usato per informarci che il microfono funzionava. Potete sottoporre le domande in qualsiasi momento, noi però risponderemo soltanto al termine della presentazione. Potete porre le domande per Jan direttamente in inglese oppure in italiano, come preferite, poi penseremo io e Abedin a fare da traduttori. Una comunicazione di servizio: stiamo registrando questo seminario, pertanto se avete problemi di connessione audio o video non preoccupatevi, riceverete tra qualche giorno il link per vedere la registrazione sul nostro canale su YouTube o sul nostro portale dei webinar. Adesso, visto che l'argomento è molto stimolante e l'intervento di Anna è decisamente corposo, procediamo speditamente con la parte introduttiva. Prima di tutto, anche se molti di voi già ci conoscono, due parole su SmartCAE. SmartCAE è un'azienda che dal 2002 si occupa di computer e data engineering, ovvero simulazione al calcolatore. Offriamo servizi di ingegneria sotto forma di analisi FEM, simulazione fluidodinamica, analisi dinamiche, ovvero aiutiamo le aziende realizzando il gemello digitale del prodotto. Siamo un gruppo di 10 persone. In quasi 20 anni di attività abbiamo svolto centinaia di progetti per numerosi clienti anche a livello internazionale. In particolare ci siamo specializzati sulle problematiche legate alla progettazione e l'ottimizzazione strutturale dei materiali compositi tenendo conto anche di tutte quelle che sono le problematiche di realizzazione dei manufatti. Per cui siamo diventati fornitori di servizi e di tecnologia per buona parte delle aziende italiane che operano nel settore. Siamo tra i fornitori di questo, siamo tra i promotori, scusate, di questo evento in quanto partner di Siemens Digital Industry Software per le soluzioni per la simulazione del prodotto FEMAP, SimCenter 3D, Nastran, Star CCM Plus, FlowFD e per l'appunto Fibersim, lo strumento per la gestione integrata di progetti e processi legati al manufacturing dei compositi. Argomento Fibersim che farà da filo conduttore in questa serie autunnale di seminari dedicati ai compositi. Per Fibersim Smartcare si occupa sia delle attività più propriamente tecniche di supporto al cliente, formazione, assistenza, mentoring, che di attività più propriamente commerciali come la fornitura delle licenze. Questa attività legata alla rivendita e al supporto delle soluzioni Siemens sono svolte in sinergia con TechValue, il nostro partner di riferimento. TechValue è una società di information technology specializzata nella fornitura di servizi IT e soluzioni PLM per le aziende che si occupano di attività di ingegneria nel settore manifatturiero, dei trasporti, automotive, general machinery e anche aerospace e difesa. In particolare TechValue è stata riconosciuta da Siemens come partner principale per il supporto delle tecnologie CAD, CAM, CAE e PLM in Italia. TechValue fa parte di VAR Group, un'azienda di Empoli, azienda IT leader in Italia per quanto riguarda le soluzioni di information technology a valore per le imprese. TechValue si inserisce nel contesto della business unit Digital Process di VAR Group, il cui obiettivo è supportare le aziende nel mondo manufatturiero attraverso la digital transformation e l'industria 4.0, aiutandole a realizzare il digital twin dei propri prodotti con le soluzioni Siemens, tra cui NX, Solid Edge e TeamCenter. A questo punto passo la parola a Abedin Gagani di Siemens per una breve presentazione dell'azienda che ci ha aiutato a rendere possibile questo seminario.
Grazie mille Francesco, mi sentite?
Sì, forte e chiaro.
Perfetto, grazie mille. Buongiorno a tutti, è un piacere essere qui con voi, mi chiamo Abedin Gagani e seguo per Siemens il portafoglio delle nostre soluzioni per i materiali compositi. Vi racconto brevemente chi siamo, la storia della nostra azienda. Siemens è un'azienda che nasce quasi 2 secoli fa come azienda di solamente 10 persone in un cortile di casa, quindi siamo stati una startup anche noi. Il motivo per cui siamo qui ancora oggi è il semplice fatto che il nostro fondatore non si è fermato lì, ma ha avuto la visione e la tenacia di creare un'impresa globale riuscendoci. Oggi siamo un'azienda molto focalizzata sui temi dell'elettrificazione, dell'automazione e della digitalizzazione, e guarda caso sono anche le ultime 3 rivoluzioni industriali, no? La prima è stata il motore a vapore. In particolare la digitalizzazione è quello che noi come business unit e anche lato Compositi seguiamo più nello specifico. Abbiamo più di 377.000 dipendenti nel mondo, e li conosco uno ad uno, e un fatturato che supera gli 82 miliardi. Se possiamo vedere nella slide successiva, abbiamo una presenza anche in Italia. Siamo in Italia, addirittura siamo in Italia da 120 anni, quindi quella che vediamo nella foto qui a casa Siemens a Milano, e anche in Italia abbiamo 440 dipendenti in 5 sedi ed abbiamo più di 4.100 clienti. Molto bene. Allora vi dico anche un paio di cose su Fibersim, quello di cui parleremo oggi. La progettazione e la gestione in generale del materiale composito si basa veramente sulle tre discipline che vediamo in questa slide, su queste tre palline, quindi quello che è la parte di disegno e di progettazione, quello che è la parte di analisi e simulazione e quello che è la parte di produzione vera e propria. Il problema per molte aziende è il fatto che queste sono viste come discipline separate, distanti l'una dall'altra. Ci sono veramente delle barriere che non permettono, che rendono difficile alle aziende innovare e sviluppare i loro prodotti in composito in modo efficace, efficiente e veloce. E questo ovviamente ha dei costi in termini di tempo e anche di scarti e anche di qualità del prodotto. Quello che facciamo con Fibersim è di veramente generare una piattaforma per la progettazione del composito, quindi quello che noi definiamo un gemello digitale, che può essere utilizzato sia per la parte di progettazione, sia per la parte di analisi e sia per la parte di produzione. Quindi da un'unica fonte digitale riusciamo a gestire questi tre aspetti insieme. Qui è veramente il grande vantaggio di questa soluzione. Aggiungo anche che come Siemens, Tech Value, Smart Kai, quindi siamo qui oggi insieme, siamo esperti per i compositi in Italia. Quello che stiamo facendo è veramente andare ad estendere il supporto che offriamo ai nostri clienti dalle grosse aziende alle piccole e medie imprese. Oggi abbiamo portato un testimonial da una grossa azienda che solamente sa un paio di cose sulla realizzazione dei prodotti in composito. Nel prossimo appuntamento vedremo anche come invece un'azienda di dimensioni medie, non si può definire piccola, trova dei grossi vantaggi da questo strumento. Abbiamo visto che avete risposto con molto interesse a questo evento, abbiamo superato la capienza della piattaforma e di questo ovviamente vi ringraziamo per l'interesse. Purtroppo alcune persone non sono rimaste fuori a causa di questi problemi di capienza e come anticipava prima anche Francesco, alla fine del webinar condivideremo la registrazione con i partecipanti, ma anche con gli iscritti che non sono riusciti a partecipare, quindi riceverete una mail nel corso della prossima settimana con queste informazioni.
Benissimo, ti ringrazio Avelin e a questo punto siamo arrivati al momento clou del seminario, la presentazione di Alpine Formula 1. Adesso lascio con molto piacere la parola a Ian Goddard.
So, yes, thank you very much for the introduction. It's a pleasure to be here today as the guest invitation to present to you a little of what we do with composites in Formula One. So yes, we've been using Fibersim for many years, and I will go into this in a little more detail and really try and give you an insight into how we engineer our composites. So as mentioned, I look after our technical and innovation partnerships, but my history in Formula One was first as a Formula One engine designer for around 10 years, and then I moved into composites design, looking after chassis laminates for many years, and spent over 10 years looking after the Fibersim process, the chassis design, and then moving on to many other composite parts, as I'll touch on in this presentation. So very briefly, Alpine. You may better know us as the Renault Formula One team in recent years. For this current season, we are now rebranded as Alpine, the flagship car brand of the Renault Group. Alpine is effectively a standalone brand within that infrastructure, relatively small sports car manufacturer, but with big ambitions for the future. So this is really the direction we're going. We're going to be a car company that goes for full electrification. And although this is about composites today, the big story here really is that obviously mainstream automotive is looking for electrification, lightweighting, efficiency of vehicles, and that really is where we're truly finding that composites will play a big part in the future of our own automotive vehicles, obviously in a very cost-conscious, controlled way, but the composite story here really does extend way beyond Formula One. So Formula One is the biggest part of what we do. It's very big part of our infrastructure. The Formula One team on the chassis side is over 700 people. As a complete engine and chassis group, we're over 1,000 staff. So very, very big infrastructures, design, manage and running the Formula One cars as you know them. But the Alpine brand is clearly much bigger than that. So again, this is where the composite story pushes into lots of other formula. We've got obviously full composite Formula One cars, and then we've got some of the sort of other formulas we do, the WEC, the Junior Racing Series, and some of the GT series of Alpine. Again, it gives us the chance to engineer composites for lots of different end user applications, which is very similar to the customer base we have on this call today. It can be very select composites, or it can be a total composites car. We do everything in between, just like many of you do on this call. The big story here is the technical partnership. So this is what really made us believe and engineer and work with Fibersim to really implement this into everything we do. Fibersim is clearly a very specialist composites design tool. I'll give you a little more insight into what that means. But what we thought is by embedding ourselves in a technical relationship, we could co-develop, we could really understand, we could work with the developers of the software, we could really push the limits of what we were trying to do with a very novel tool. I must admit we've been using this for around 20 years now. I'm sure you're all aware how the composites industry has moved on in 20 years. In mainstream automotive, it's just emerging. In Formula One, clearly we've been doing this for a very long time. And it's really that long story, that journey that I can show you today of how Fibersim has really helped that critical transformation to really control and define everything we do. You're all familiar with the strength, the lightweighting of Formula One cars, totally reliant on the performance of composite materials. And this story is really how you get that level of confidence in engineering composite materials for the extreme environment that you see them operate in Formula One. Where we are today, every single composite part on that F1 car is designed, manufactured and controlled using the Fibersim process. So the quick story here, it's all about materials. You're very aware that Formula One has a pretty open menu for looking at advanced materials technology. Very exotic aerospace materials are widely used, but I guess also we've got these sort of developing very topical materials areas. Additive manufacturing is clearly very, I guess, new, supported within the Siemens infrastructure as a digital engineering, digital twin workflows that Aberdeen was mentioning. But the big story here is composites. The lightest of all, the best specific strength of all the materials, but really the design creativity to do something different. We're not just going to take a metallic part and recreate it in composites. We can actually think very differently and very creatively in how we work with a composite material. And that's really where Fibersim starts to help us visualize this process. But these are exotic materials, right? So yes, they've got a place in F1, they've got a place in aerospace, but what about more mainstream areas? That could be automotive, it could be wider, infrastructure, transportation. I guess this automotive story, as I've mentioned with Alpine, clearly the direction that the automotive world is taking today, very aggressive international legislation, sustainability, clean emissions, push to electrification, lower carbon emissions from the sort of traditionally powered vehicles. All these mean very aggressive weight reduction targets for the auto manufacturers. So again, naturally, this is where the audience here are sort of representing the composites manufacturing industry are really in a strong place to help the automotive OEMs looking to make this move to composites. How can you help engineer these parts so that the world's automotive can lose 20-30% of a vehicle weight? Very aggressive targets and only realistic if you start to look at something like composite materials. So let's take a look. What is this Formula One composites process? What makes it so different? How does Fibersim really help us be more creative, really drive that competitive advantage? What does it do for us? So as I mentioned, I've been doing this a long time. I think one of the hosts on this call kindly likened me to the Cristiano Ronaldo of Fibersim. That might be a bit too much of a stretch, but I guess I've been doing it for a long time. So way back in 2007, I got involved, but that wasn't the start of our Fibersim story. I was actually the third Fibersim user in this team. So we had the software, we were kind of getting our heads around what it could do, but what we really thought way back in that sort of time scale was, how do we really embrace this tool? What can we push the limits to? What can it really do to help us drive the performance of a composite Formula One car? So again, materials, yes, there's lots of exotic materials. So why above all do we put so much of our emphasis and resource into composite materials? Composite materials in a Formula One car make up about 80% of the F1 car by volume, but that only accounts for 20% of the weight of the car. So it's those kind of ratios where you start to realize that actually engineering investment in composites is above all so much more important than all of those other exotic aerospace materials that you see there. Composites really does let you do things differently, as we've obviously come to learn in Formula One. The other big story in, I guess, if you look back at the history of what we've done with composite materials in Formula One, is it how you slowly re-engineer parts to be composite parts. A lot of this can come down to part simplification, part consolidation. Can I take a traditional metallic assembly of 10, 20, maybe more, lots of parts and consolidate those into a single composite part? Again, the geometry limitations, the complexity, the things you can do with the forming of the composites really means you can have a fresh look at how you design things. And obviously part consolidation, reducing the number of individual parts, reducing the assembly, actually helps offset a lot of the costs of the composite materials in the first place. So the net change in cost isn't actually as extreme as you might think when you start to re-engineer composite materials properly through this whole kind of digital life cycle of what the part is. So the process. What to us is the workflow of composites, and how does that relate to you, the audience, in doing very similar processes? I guess whichever industry you represent, the process will start with some kind of design evaluation. For us, that's the aerodynamic definition of the car. In our road car industry, this would be the styling process, effectively defining the shape, the form of the finished vehicle before we then start to look at the structural properties in the full-scale design. This is no different to any other industry. We go through design, stress analysis, CAE round trips, the normal iteration to really optimize the design. Then we come to a much more manufacturing driven focus. With composite materials, clearly you're going to need some tooling, some jigs, some fixtures. We've got the composite laminate design itself. Within that laminate, there's like to be core materials, inserts, bonded assemblies, so other things that we need to consider. And then there's the part drawings. This is where really I mentioned Fibersim's application for the first time. So we can take this full digital workflow right from the conceptual design through the CAE, through the manufacturing, the laminating, the templating processes, and really tie all of those in to the sort of single digital workflow that Fibersim provides us. So what we're talking about here is a very integrated, very end-to-end way of working with composite materials. And we're no different to you in the way that we manufacture these parts. We're still talking about hand layup, pre-preg materials, very skilled laminating workforces. So you might think that's very non-digital. So what we're talking about here is how to introduce a Fibersim workflow that can really pull in a digital twin mindset, a digital workflow, using all the capabilities that a digital workflow brings you, but to really, I guess, control and refine a hand layup process. We might think, well, what are we actually trying to achieve here? We've been doing composites for ages in Formula One, but so why would we need to change? If I go back a very long way, I dug out this drawing of over 20 years ago. This is a nose assembly off an F1 car, done in the very traditional manner. So lots of cross sections, lots of shaded patches, lots of information about where the plies are going to go. The limitation of this is it takes a very, very long time to draw. This is a beautiful hand-created illustration by a very experienced design engineer. The sections are all, I guess, theoretical. It's how the designer imagines those cross sections are going to look. So we've got lots of cross sections down the nose assembly. And we've also got the difficulty of a cross section tells you exactly what happens at that cross section. What happens where one cross section transitions to the next cross section? What happens if it's a complicated 3D shape and you can't really explain it with a single cross-section? And this is where a lot of our traditional composites, whether it's done with this method or hand-drawn ply books, even some of those could be done in non-CAD tools, it was very much an illustration process. It relied on a lot of skill between the designer and the production team to try and understand what the intent was. It was never clear, it was never fully defined. We probably relied too much on experience and skill to undertake our composites processes. So yes, this is very old, but it was clear there must be a better way to do this. And that's really where, for us, the solution was Fibersim. So how can we get that level of detail in a very methodical, very controlled workflow where you don't need to be the most experienced laminator or designer in the world? We can have consistency, reliability, quality, repeatability. And that was really the mindset of let's take on Fibersim. Let's really push what we can do with this. And not only do the design process, but also, as I mentioned, how can we integrate that manufacturing workflow? As everyone knows, within composites, it could be laser placement, it could be flat pattern templates, the nesting software, cutting machine integration, automated manufacturing systems. There's so many third-party systems that you want to tie in to effectively define this composites process. You clearly need a very powerful system that's designed around this composites mindset. This wasn't an instant journey for us. You know, we're very cautious in Formula One. Again, we've got a lot of experience. We don't always believe that everything's going to be better than we know, I guess, you know. Maybe we're a bit stuck in our ways in that regard. So the Fibersim story was very interesting to us. The idea of digital simulation and digital workflows were very new. If you think back 20 years, 15 years ago, today they're the default. So really this was, I guess, a very early digital workflow. So how we started with this is we took on the most difficult job that we do, the Formula One chassis. The Formula One chassis is around 1,000 individual plies of material, insanely complicated geometries, lots of material, lots of optimized patches of laminate. Clearly that was so difficult, we were starting to realize we couldn't do this without a dedicated specialist tool. So if we look at the period up until 2007, Fibersim was just for the chassis. Let's just let it work on the most difficult job that we cannot do without it. That then established the workflows, the way we work, so it made sense. Hey, what else can we do? If it makes the chassis easy, can we apply that mindset to other things? So the transition period then was the 2007 to 2015 period. So this was when I got involved and started to really see, could we look beyond what the chassis design team do? And this is where we started to look at all the other structural parts, the wings, the bodywork, the suspension, the crash structures, and really refine those Fibersim methodologies in a scalable way that we felt comfortable with. Again, there's a lot of history, a lot of processes to transition. So this is a really progressive way of defining how should we do composites, because Fibersim can really help support that change. That then led to, hey, wait a minute, if it's this good for the big things, why don't we just do it with everything? So again, this was really the next milestone for us. So around the 2015 time period, we moved Fibersim to 100% of our parts. It doesn't matter how small, how simple the part is. It could be a small bracket, a small aerodynamic fairing. It could be a complete crash structure or a wing. Every single part is now Fibersim defined and processed, really giving us the benefits that we've seen on the difficult parts and applying them for the same consistency and repeatability in everything we do. So that's seen us jump from 2 to 3 to 15 designers. And in that 2015-2016 period, where we launched the 2016 F1 car, fully designed and manufactured using Fibersim-based processes, we were then up to a pool of over 30 design engineers, all using this Fibersim workflow. So it really has been a game changer, but again, it can be progressive, it can be scalable to suit your individual needs and your individual industries. But it does have the process to go to this 100% that we genuinely work at today. This is obviously a software-driven process, and it really does give that, I guess, quality and consistency. What we did with the implementation of Fibersim was really control our workflows by bringing in very specific methodologies, very specific ways that we define the process. this is what actually helps us define and control the hand layout process, really bringing digital methods into human interfaced manufacturing. Another big important feature of Fibersim, which is unique compared to its leading competitors in the marketplace, and again is really, really a strong point, is the open architecture. I mentioned that the composites workflow touches so many different manufacturing methods and processes. You really want to be able to integrate with either the best in practice solutions you're looking at or existing infrastructure you may already have. You don't want to be forced to have a sort of single shop source where you have to have all of the tools when it makes sense to have this open architecture mindset. So again, this is where Fibersim is very class leading, but offers all of the integration you need for your choice of nesting, cutting, lasers, material management, all of the third-party tools that really support this true digital twin workflow. As I mentioned, we're hand layup. So again, I guess that's very much like the user experience base on this call. We've got a very large facility. You can see the image there. That's about 1/3 of our in-house clean room facility. 80 laminators, full digital workflows. So all of the documentation is on the screens. You can see they're large touch screens with ply books generated in Fibersim. All the documentation is digital just to mean that we can update it very seamlessly, automatically. Laminators can work in different areas of the room and access their work. We're a big facility, over 80 full-time staff, 30 different materials. We use something like 25 kilometres of material a year to produce 25,000 composite parts. The turnover in Formula One is immense, as I'm sure you imagine, the pace we upgrade the cars through the season. It really does mean that it's a very large in-house facility. So this end-to-end workflow, I've given you the context, but really, again, I can't go into too much detail, but let me try and give you a flavour of what the Fibersim process is. So we're now going to take less than 5 minutes to do the full design of a Formula One diffuser. So you're all familiar with the floor of the diffuser of an F1 car, the great big piece under the full length of the car, probably 2.5 metres long, diffuser exiting at the rear, around 200 or 300 plies of material in here, and it's a fully consolidated closed mold laminate. So can we really design this in 5 minutes using the Fibersim methodology? Let me show you. The first thing we do is we have a CAD surface. So this is our aerodynamic or styling surface, as you want to call it. So we can take this very early on in the design process. We know some of the tooling limits. We know where we want to split the mold, where we're going to have some different features or edges. We can really start to define the basics of what the geometry will look like before we even think about the laminate. The stress team, the CAE engineers, will obviously be working on the laminate definition, trying to understand what the aerodynamic loads will be, what the FIA load tests need to be. So we can work with the CAE team to define a laminate. This is split between the design team and the CAE team. The design team work with Microsoft Excel to draft how a laminate will look. They also work with the stress team who are working in ways to define the laminate, the materials, the geometry, and we can basically import that very seamlessly, very quickly into the CAD workspace. We now have the starting of a CAD laminate. What we need to do here is define the ply boundaries. So these have been digitally imported from CAE. We can now refine, tidy these up, maybe add in some ply drop-offs, some automated functionality again that Fibersim can help create for us. So some very simple ply boundary shapes can start to be defined on the 3D surface. The next step, think of it like cookie cutters. We want to intersect some very basic geometry to define what the ply boundary will be. You can see the ply boundary in yellow on the screen there, and we've got these very simple extruded profiles that are parametrically offset to define those ply boundaries. It might look complicated at this stage, but what we're really doing is just intersecting basic geometry so we can get some very, very defined ply boundaries. So what you can see here, again, we've got the yellow ply boundary that we've just constructed. And because it's parametric, we can offset it in different directions by different amounts to get these very controlled automated drop-offs. Again, Fibersim is very advanced in helping you specify drop-offs on different edges of parts. So this is an automatic feature that lets you define very complicated but very controlled laminates. This is the inner laminate or the undercore laminate. We can then overlay the overcore laminate. And again, you can see the resolution and the detail that we can have here. We can nest the overcore laminates in between the ply drops of the undercore laminate, levels of detail and definition that just wouldn't be possible in that old school cross-section hand-drawn ply book approach. So what we're doing here is very, very complicated but very refined ply boundary geometry. What this also lets us do, I've now jumped from the floor to a cross-section of a rear wing. Rather than creating these cross-sections manually, wherever you can cut a plane into your geometry, Fibersim can give you a fully automatic instant cross-section. So this can be very useful as a designer. I can see where the plies are on the job, has the part consolidated into the trailing edge of this rear wing, for example, and this can also be used by the manufacturing team. The design team can provide standardized controlled 3D cross sections. What our manufacturing team also do is they have the ability to use the 3D CAD and to create their own cross sections. If they want to look at a piece of geometry and understand what the laminate looks like, they can. Again, it's the flexibility that this digital model gives you at all stages through that design and manufacturing workflow. The next stage in our 5-minute Let's Design a Floor and a Diffuser is the documentation. So no more manual drawings here. This is fully automated. You set up some templated views and you just tell Fibersim to get on with it. So to us, this is a convenient time for a coffee break. We come back from the coffee break. We have a fully documented ply book, as you can see here. So rather than the complicated drawing that you saw of the nose from 20 years ago, we've now got a very logical step-by-step manual. So just like your IKEA handbook or your Lego manual, we've now got a Formula One car that you can build with a Lego style manual. Very simple, very clear, controlled lists of the plies that you fit in each stage, no margin of error and guaranteed repeatability and accuracy. Along with this, we've also got an automated ply check sheet. So this is a list that's used for the sign-off as the laminator creates the job, but it's also used as a material checklist. So very quickly, we can generate a checklist like this, give it to the cutting room team, and they can have a quick look at the materials they need, the different material types, any special operations that go in there. And using Fibersim, we can also get a very quick estimate at the length of material likely to be needed for this job. So we can allocate markers and material roles very early on in the process before we've even started the templating. Now to give you a very quick flavour of templating. So a big part about working with carbon fibre is how long it takes you to prepare the templates. We all know carbon fibre material is very expensive. Well over €100 per square metre for the kind of stuff we use. It's expensive. You want to get your templates right. So that needs a lot of confidence in taking the 3D design and creating 2D templates from that. The traditional way is for the laminators to prepare paper, tape, templates on the job. That's very slow, very time consuming. We want to do it digitally, but we want to do it digitally right first time. Fibersim is the way to do this. We now 100% digitally template all of our work. No manual templating, no verification of templates. Fibersim does it. We hit cut on the cutting machine. Very direct, very quick. The reason we've got this level of confidence is we've been through the optimization. So Fibersim gives you very simple drape simulation tools. So if we start with picture number 1, that was what the stress engineer intended. We know we can't actually make that. Fibersim shows us we can't make that. The yellow and red bits mean it would be very challenging to try and create that part. This is actually a big piece of material on a Formula One chassis, so you can imagine it's quite a big piece of material to work with. You want it to be going down well. Picture number 2 shows the same geometry split into 2 plies. Very quick thing to do, and we can see that we've already improved the manufacturability immensely on that. We can talk with the stress engineers, we can understand if that's acceptable. the stress engineers tell us actually they prefer idea number 3. Yes, we can split it, but could we split it somewhere else? We can actually see now that we've got an even better definition of ply. It's all blue. Fibersim is going to prepare us an absolutely perfect template, no issues. Picture number 4 goes one stage further. We've now taken what we've done with number 3, but we've added an overlap just to make sure that we can split this ply without any structural degradation. We've overlapped the ply. So we've gone from picture number 1 to picture number 4, which gives us the total confidence that we can now manufacture this. Very quick, very simple, and this works for very big parts, as you can see. So this exact process, we take the chassis mold in 3D, we do the drape simulation in Fibersim, we create the templates you see in the bottom left of the screen, we take those templates and we then directly cut them into the pre-preg material you see the laminators working with to fit into the mold. This gives us the super fast turnaround you need in Formula One, but also the very accurate repeatability that every chassis we make is the same. Those plies are being positioned using laser ply placement, so there's no margin of error, completely repeatable. When it comes to the flat pattern shapes themselves, again, something that's unique to Fibersim is the ability to nest groups of plies using the same origin point or seed point for your simulation. Other software utilities let you create templates, but no other software utility lets you nest them in this way. And again, this is a big part of giving our laminators confidence in Fibersim templates. If you can nest all the plies together using the same seed point, the laminators can see the plies and they look as they are expecting. If you use one of these interactive simulation tools, the plies might not necessarily all sit together happily like this. They might have different curvature, different shapes. They'll still work, but it just doesn't give our laminators the same confidence as the Fibersim method that you see here. I mentioned 100% accuracy. What we're doing with our plies, some we send down as net shape, but some the laminators actually ask for them to be oversized. Sometimes it can be easier to have maybe 3 net edges perfect and 1 edge oversized, just so they're not like trying to fight it or pull it to a mold edge where the shapes are really complicated. So again, within Fibersim and by learning together with our manufacturing teams, this is how we get to 100% accuracy using net shape patterns where required and oversize if some of the shapes are really challenging, and by giving a templator, a laminator, a net shape template, it could actually slow down the process compared to giving a slightly oversized piece of material that still trims to the job. So again, be flexible with your mindset in how you use the templating, and you really can get this 100% accuracy straight to cut cloth process. This then all gets automated into the nesting. So again, a single button export feeds our nesting software, and the markers and the templates can be prepared for cutting. So again, very quick manufacturing jobs there. And that gives us a very, very quick walkthrough. I appreciate that was quite a lot to give you in such a short workflow, but what really are we talking about here? The big part of this process is this end-to-end integration. It doesn't matter which department, which role, you've got access to the Fibersim model, so everyone is seeing the same data. And this is really important for us to have this consistency and repeatability going through digital, the documentation, right through to the markers, the flat pattern, the templates. We've all got the same way of looking at the parts. And a quick visual example here that's a great way to show that. We've got the very first idea that the CAE and design engineer had in the left-hand picture. We've got the very same ply fitted in the mold from a net shape cut Fibersim template, and it's exactly the same. The repeatability, the consistency is there. And this is really what Fibersim brings you in this, I guess, total control that gives us the confidence and also the quality and the repeatability in the manufactured parts that we're using. The big part here is this kind of digital workflow, the closed way of just controlling everything we do. Fibersim really drives this end-to-end process, but brings in, as I said, the third-party tools, this open architecture mindset. We can use the best process and the best each department to really drive this Fibersim integrated workflow. To sum up, and this is really where some of the biggest metrics are, what did we actually gain by this long transition from those very, very complicated hand-drawn illustrations to a now total digital push button ready to go Fibersim workflow? The overall development time reduces by around 60%. This digital sharing of the ply boundaries, the templates, is a real game changer in terms of the workflow. To take one example, that CAE import process into CAD, that used to take us 2 weeks for a race car. Very intensive, manually translating geometry files in 3D from stress tools to CAD tools. Fibersim, you push a button, it takes around 2 hours, job done. 2 weeks to 2 hours, you kind of get a feeling why this might be worth looking at. The design time itself, we genuinely save around 20 to 30% of our time there. You may spend a little more time in 3D defining the plies, but the payback in the game with all that automated documentation is very, very significant. The laminating time, because we've removed all the need for manual templating, we've got digital cut templates, they're put straight in the mold, positioned by lasers. That really was a game changer, something like 80% reduction in manual versus Fibersim controlled workflows. And again, I won't run through all the metrics in detail, but it's that kind of saving. I guess the biggest consistency of all is the consistency of the parts. The weight variation dropped by a huge amount, but the repeatability and the positioning of the plies also became much more accurate. That is a part of the round trip story, and that gave our designers and our stress engineers much more confidence to reduce safety factors, reduce knockdown factors, reduce margins really on what we're trying to achieve. If we know we're producing the part more accurately, we can actually be a lot more ambitious with the original design specification. So I appreciate that's a huge amount of information to give you a quick taste of Fibersim in Formula One, but hopefully it gives you an insight into the importance it has to us and why it's really revolutionized what we do with composites at Alpine. So thank you very much.
Thank you, Ian. Thank you very much for your presentation. I found a lot of very interesting hints and suggestions on how to improve the workflow of the composites using Fibersim. I'm taking back the control. Torno io a essere relatore e ci avviciniamo, diciamo, alla parte conclusiva. Ora non so, Abedin, se vuoi essere te a riassumere molto brevemente quelli che sono alla fine i vantaggi di Fibersim nel contesto di Alpine.
Sì, Francesco, sarò molto breve. Lo possiamo riassumere veramente in una slide. Fibersim riduce di molto, veramente il supporto di uno strumento digitale riduce di molto il tempo necessario allo sviluppo e alla definizione quindi di una parte in composito, ma riduce di molto anche il tempo necessario poi ad utilizzare questa informazione, questo dato, per creare la documentazione che ci serve a realizzare la parte, ovviamente se vogliamo fare una parte che sia coerente con quella che abbiamo disegnato e progettato. Purtroppo non è sempre così, non è sempre comune. Una cosa è l'intenzione del progettista e una cosa è quello che si ha alla fine come risultato. E poi anche l'interazione con la parte di CAE, quindi di analisi di elementi finiti, di analisi strutturale o di vario tipo. Non si deve, una volta che una parte è stata modellata, non vediamo veramente il motivo per cui si debba andare ad utilizzare del tempo in più per sistemare il modello e poi analizzarlo. Tutto questo possiamo veramente riassumerlo. Nel caso di Alpine abbiamo fatto anche studi che abbiamo pubblicato qualche anno fa ancora con il vecchio brand di Renault, una riduzione del tempo di sviluppo, o meglio un'accelerazione del tempo di sviluppo del 60%. Questa è una metrica rappresentativa in questo caso.
Perfetto, ti ringrazio molto. Prima della sessione domande e risposte, un'ultima slide, giusto per ricordarvi l'evento che terremo il 22 di ottobre, dove scenderemo un po' più nel dettaglio delle varie fasi del workflow con Fibersim e in questo caso illustreremo i benefici di questa soluzione non tanto nel contesto di una grande impresa, di una grande azienda come la Formula 1, ma in questo caso nel contesto delle aziende manifatturiere anche di media dimensione, come tra le altre cose vedo l'elenco tra i partecipanti, buona parte dei partecipanti a questo evento. A questo punto siamo arrivati alla sessione di domande e risposte che stanno arrivando attraverso la chat di GoToWebinar. Come vogliamo gestirle? Vuoi prima introdurre la domanda in italiano e poi tradurla in inglese per Ian?
Certo, possiamo fare così allora.
Ok.
Va bene, allora, io leggo finora una domanda nella chat che è quali sono le differenze rispetto ai moduli CP e CPM di CATIA. Su questa domanda potrei fare anch'io diciamo, potrei rispondere anch'io delle informazioni al riguardo, ma magari prima chiediamo a Ian se vuole commentare. Ian, there is a question here on the chat. We would like to have your opinion about what are the differences. There is a question on the text box on what are the differences with respect to CATIA's composite modules, CP, CPM. Do you want to answer this question, or do you want to leave it to me?
I'll cover it very briefly, but leave it to you, I guess. I mean, we chose Fibersim because of the total integration of the workflows. We are using CATIA as our design CAD package, but we chose Fibersim for the integration, the workflows, the methodology refinement that we could really do. We just felt that it suited much better the depth and the complexity of the work that we wanted to do when that original decision was made to choose Fibersim long ago.
Thank you very much, Ian. Potrei aggiungere anche qualcosa in italiano su questa domanda. Secondo me i fattori principali sono due. Da una parte c'è l'architettura, come Siemens, quello che noi abbiamo scelto è un'architettura aperta, per cui Fibersim si interfaccia con diversi CAD, riteniamo che si possa portare del valore aggiunto al nostro cliente anche sul CAD che sta utilizzando, quindi lo specifico CAD gira su NX, ma gira anche su CATIA e anche su Creo. Ci sono anche dei vantaggi in termini di precisione delle simulazioni che si possono fare, dei flat pattern che si utilizzano. Per questo posso rimandarvi a un case study che abbiamo pubblicato di recente con un nostro cliente, con Toyota Racing, per la parte di auto da corsa, nella quale il nostro cliente in realtà ha fatto questo confronto ed ha poi deciso di optare per la nostra soluzione con delle metriche anche un pochino più precise. Spero di aver risposto a questa domanda, poi se ci sono ulteriori dubbi non esitate. Ok, allora passo alla prossima. So this is for Ian. Hello, Ian. Could you give differences? Could you give differences in terms of cost between Fibersim solution with 30 licenses and expert Fibersim designers to pay respect to old-fashioned composite design? Which is the cost save, if any, in using Fibersim?
I think for here, it's very much about getting that methodology and that workflow. I mean, I quoted some metrics where we've saved huge amounts of time and workflow in the process, but I think it's more than that. It's looking at how do you actually engineer the best composite parts? And that's really part of the considered cost. So yes, Fibersim costs clearly need considering, but a Fibersim skilled design team, I think, produces much better output, much more creative. So I think it's part of a bigger question. It's not just financial, but I think when you look at the efficiencies, the manufacturing integration, the end-to-end process, I think if you look at the time spent through that process, that's where Fibersim does justify its value. And really that manufacturing integration, the huge saving in the templating, the cutting, that value is, in Formula One, it's about speed to track, and that's as important as the cost. But I think when you look at the whole process and how much Fibersim integrates, it's not something you really compare directly to the cost of a designer versus the cost of a Fibersim seat. I think that combined value is greater than the sum of the two individual parts.
Thank you very much. And then the next question, how do you define the best layup sequence for each part?
So that's quite a complicated question, I guess, to answer. It's really, again, many years of experience, and I think Fibersim helps us visualize that. It stimulates the conversations between the CAE team and the design team to help form what is the best laminate build-up. I think what we've done with Fibersim is we can optimize much more aggressively than we used to. So whereas, I guess, if you look at simple laminates, you might just do lots of all-over material coverage. That's not the best way to use composites. But if you've got a tool like Fibersim that lets you define much more complicated laminates, edge boundaries, drop-offs, ply packs, that's really the opening point to start being more creative with your laminates. So yeah, I think Fibersim is the first step. Understand how to do the methodologies, the difficult geometry. Then when you've got the capabilities to do that, that's when you can really be aggressive with the laminate definition, the layup strategies, and obviously the CAE side of it. There's many different philosophies of best laminate stacks and methodologies.
Thank you, Ian. I would also add a comment from my side. I will do it in Italian just for simplicity. C'è anche un ulteriore metodo con il quale Fibersim può aiutare nella definizione della sequenza di laminazione, ovvero tramite diciamo automaticamente con un semplice bottone permette di fare questo, diciamo, se vediamo le pelli come carte, permette di rimescolarle in modo da minimizzare quelli che sono i drop tra un apply e la successiva. Ok, quindi andiamo alla prossima domanda. Esistono possibilità di analizzare i flussi di resina o gli scoppiamenti dei materiali durante lo stampaggio? So yeah, the next question is it possible to analyze the resin flow or the materials deformation during stamping?
So we don't do any stamping, but yes, I mean, I know Fibersim has got some forming simulation tools within it. We only use pre-preg material in hand layup, so I do not have direct experience of that, I'm afraid.
Yes, thank you very much, Ian. I can actually add something to that. La risposta è sì, è possibile analizzare i flussi di resina, la deformazione del materiale durante lo stampaggio e anche alcuni fenomeni che sono un pochino più complessi come lo spring back, quindi la deformazione del materiale poi fuori dallo stampo, tramite un flusso di lavoro che comprende Fibersim, ma anche la parte di simulazione con SimCenter 3D, e su questo i nostri amici di SmartCAD sono sicuramente molto esperti e possono aiutare. Per quanto riguarda gli scorrimenti dei materiali durante lo stampaggio, Fibersim ha introdotto di recente in una delle ultime release la possibilità di simulare proprio lo stampaggio e ci dà proprio queste informazioni su come il modulo standard, su come si comporta il materiale quando facciamo una simulazione di stampaggio. Ok, la prossima domanda è quanto secondo voi un CADista deve diventare un esperto di analisi strutturale e viceversa? Ad oggi le due figure sono ben distinte e separate. Ok, immagino che la domanda sia, diciamo, l'interesse sia di capire qual è il punto di vista di Alpine, quindi la giriamo a Ian. So Ian, the next question here is, in your opinion, how much a designer should become an expert in structure analysis and vice versa? Because today these are quite separate experiences or quite separate people really.
Yeah, so I guess Formula One, we've deliberately kept it quite separate. So our design engineers are a separate group of people to our composite CAE engineers. That's really just for speed of workflow. Both those teams can work in parallel rather than sequentially. So we choose to do it that way, and we've got very advanced non-linear FEA composites engineers in the CAE team, and we've got more packaging and structural engineers in our composites team. So I think we are seeing a move where those roles are moving closer together so that one engineer can engineer the whole process. But I think in Formula One, we're still choosing to have CAE specialists and design specialists who work together just to increase that speed of turnaround.
Thank you very much, Ian. Vedo un'altra domanda che relativa a una domanda di poco fa, quindi sull'ottimizzazione dei layup. La domanda è quindi nessun tool specifico di ottimizzazione del layup. Allora, se la domanda è relativa alla parte strutturale, quindi se vogliamo capire in termini di analisi strutturale, di comportamento meccanico, qual è il layup specifico, sì, lo possiamo fare tramite l'interazione tra Fibersim e SimCenter 3D HIDS. Quindi HIDS è un modulo di SimCenter 3D per l'ottimizzazione strutturale, che va a vedere quali sono i layup più adeguati e ci permette di fare questa cosa. Magari faccio la domanda, provo a fare la domanda di nuovo a Ian per capire qual è il punto di vista di Alpine. So, Ian, there is a further question related to a previous point, which was about layup optimization. So the person is asking if you have any methods to optimize layup on a structural point of view.
So again, yeah, I try to keep it fairly brief, but in the CAE world, you've got two basic approaches. You can do a zone-based ply stack, or we can do a individual ply-based stack up. So the CAE engineer has two approaches to whether they're doing a generic laminate or a very detailed laminate. We then look at three main failure analysis modes. So the first is just static first ply to failure. The other methods we use are SciWoo, Sci-Hill, again, different laminate failure theorem. All of these different laminate failure methodologies are packaged in things like the Siemens CAE tools. So that's obviously a good starting point. There are other tools, you know, laminate tools, laminate modeler. There's a number of different tools on the market that again integrates into Fibersim, Beta CAE and ANSWER. There's lots of different choices out there for how you define the CAE laminate that you can then work seamlessly and integrated with Fibersim. So really, I guess it's define whether you're doing zone-based or ply-based CAE, decide which laminate failure theorem is right for you, and then work with the Siemens team to understand which are the best tools for the geometry integration into Fibersim. I think working with geometry that can be truly bidirectional is another big key to the efficiency that I was talking about in the workflows.
Okay, thank you very much, Ian. And I already have another question for you, which is the person that is asking this question wonders whether Alpine has ever used Fibersim for other processes rather than hand layup. So, for example, one could be filament winding in this question.
No, again, we're very limited in the way we produce Formula One cars, and we just use pre-preg material. So I'm afraid we don't have direct experience of filament winding, fiber placement, RTM, and some of those other processes. They're things we will likely be moving to more within the Alpine road car infrastructure, but that will be new to you, and I guess we're going to be coming to you for help on that one.
Okay, I look forward. Very good. Then there is a question about characterization. So I will first read it in Italian and then in English. Quali sono i metodi di validazione sperimentale affinché il pezzo realizzato sia affidabile? So which are the methods of the experimental validation methods to make sure that the piece is actually that you can trust basically the simulation?
So when it comes to composites testing, obviously we do a lot of virtual work. So our CAE team have got lots of models, static and dynamic, linear and non-linear, to understand our load cases. We validate that against a lot of in-house static load testing. So we've got hydraulic rigs that can do very high loads on static rams, hydraulically loading the parts. When we test composite parts, we also have acoustic systems in place. So we use acoustics, we use ultrasound to monitor how the composites are maybe being damaged internally, non-destructive testing techniques. But acoustics, while you're doing static load testing, is something that we've learned a lot from in terms of the adhesive strengths, the internal bonds, just how the laminate might fail or shear internally as we develop those. And I think that process then feeds back to what we do in our virtual CAE world. And again, we've just got good experience around that. We do all of that work before we take a Formula One car to the FIA crash tests, and we generally have very good success rates with those tests, again, just because we've done so much static load work in our laboratories.
Thank you very much. Yeah.
Okay, io mi fermo, ci sono già ancora altre domande, ma stiamo andando un po' lunghi come tempi, per cui io mi scuso con coloro a cui non siamo riusciti a rispondere ai loro quesiti, ma dobbiamo procedere con la parte finale del webinar.
Francesco, posso farti una domanda solamente? È possibile rispondere magari a queste persone poi via mail?
Certamente.
Diciamo...
Noi abbiamo traccia delle domande e risponderemo ovviamente per posta elettronica. Manderemo i quesiti a Ian e chiederemo la disponibilità per darci una risposta per posta elettronica. Ecco, lascio a te la parola soprattutto per questo tema qua che avevamo anticipato a chi si era iscritto al webinar e ha partecipato al sondaggio al quale ho visto hanno aderito molti partecipanti.
Sì, ti ringrazio Francesco. Allora avremo poi una comunicazione al riguardo per questo. Comunque vi abbiamo mandato un survey con un questionario con la promessa che un numero limitato tra chi ha risposto avrà l'opportunità di ricevere del merchandising brandizzato da Alpine F1 Team e anche vivere un'esperienza virtuale nel mondo di Alpine Formula 1 durante il fine settimana del Gran Premio di Istanbul, che sarà domenica 10 ottobre. Le persone verranno contattate via mail al termine del webinar, quindi credo già questa sera. Quindi ecco, stay tuned e grazie per aver risposto al questionario.
Perfetto, siamo arrivati al termine di questo seminario. Vi ricordo che il prossimo appuntamento è il 22 ottobre alle 14:30, sempre per parlare di materiali compositi, sempre per parlare di Fibersim, sempre in compagnia di Abedin, ma questa volta con un'altra azienda che sarà Sparco e riporterà la loro esperienza. Con questo io ringrazio tutti i partecipanti, ringrazio Abedin, Davide Ranaldo di TechValue che ha contribuito alla realizzazione di questo webinar. And for sure, absolutely, I thank Ian for his very nice presentation. And auguro a tutti quanti un buon fine settimana. E adesso